In the first video, we explained the functionality of the visualization software and how you can use it with ParaView. We saw a table of data converted to nice visualization and how ParaView's feature can further improve the visualization quality. This video focuses more on the details on how you can do such visualization using your data. The process of converting data into visualization looks like this. The first step starts with preparing data. Your data must contain the XYZ coordinates of each particle for visualization. Other than the location of a particle, you can also add other variables such as scale, which control the size of each particle, or ratio, which can control the shape of each particle. As an example, the variables used to visualize this 3D visualization contains the location of each particle, XYZ, and size of the particles. Then you need to process data into VDK files. This involves running run.sh. In run.sh, you can set a configuration of how you want to visualize the particles. You will need to specify the folder location containing the data files, folder location to save the processed VDK files, and columns inside data to tell the program which column corresponds to which variables. In this case, there is scale, X, Y, and Z. You can also add other arguments for customization. Then, when you run run.sh on a terminal, it tells some information about the processed data. This is a demonstration of what it looks like. On the next step, you need to load macro for visualization in ParaView. We need to add an additional function in ParaView to visualize processed VDK file. The function visualize.py already exists in GitHub repo. You just have to load it in ParaView as macro, so you load it from this icon, and it creates a button you can use. In the last step, you need to load the processed VDK file and run the macro in ParaView, and the visualization is complete. You can load your data from File and press Apply. Then, on the loaded data, you want to apply the Python macro for visualization. And the visualization is complete. That's all the steps, and here's a recap. 1. Prepare your data. 2. Run run.sh in your terminal. 3. In ParaView, load macro, which is visualize.py. 4. In ParaView, load your VDK data and run macro. And the visualization is complete. After we finish converting table data into ParaView visualization, I'll walk through some features in ParaView to enhance the visualization. ParaView also allows you to visualize time series data. When you have a lot of data which represents particles at different time steps and want to see the animation of how they dynamically move, the program first sorts the dataset alphabetically by their file names, then each of them is transformed into VTK files, and the program can bundle those VTK files together to create a VTK time series file. The procedure to achieve this is almost the same as when you're dealing with the static data. In run.sh, you just have to specify argument, say video, and run run.sh, and that's all the steps it takes. The procedure in ParaView is also very similar. You first load VTK time series data, then run macro to visualize it. To watch your particle moving dynamically, you just have to press this green button here. Since you loaded VTK time series data, the particle should move. You can also save the animation or adjust the rate of transition between one frame to another. To do this, you press File, then press Save Animation. Then I type some random video name, and this screen shows up. And in here, you can adjust image resolution, coloring, as well as image quality. And another important feature that I like to mention is frame rate. So this is essentially the same as FPS. And you can, by changing this value, you can adjust the rate of transition between one frame to another in animation. And essentially, greater this value, faster the transition becomes. So if I make it like 10, the transition becomes really quick. Things work in the same way for three-dimensional data. And here's an example. You can define a color of particles based on the input scalar corresponding to each particle. Say you want to color particles based on their x coordinate. You first need the input scalar as x. These input scalars is dependent on the data you have. So you can manually define some input scalars you want to use for visualization. In this case, I choose x and press apply. And once you select X in coloring, the result should show. As you can see, based on the X coordinate of the particles, they have different color. If you would like to customize this color, you press Edit in coloring, and Color Map Editor should show up. ParaView's got some handy predefined color palette you can choose from. They look pretty nice. If you like to create your own customized color palette, you can select it in this screen. So say you want to have different color for X coordinate 2, you press it and say I want a green, and it shows up. You can also adjust the transparency to add some emphasis on particular colors than the others. Resolution defines how many points are used to create meshes and render each particle. Higher the value of resolution, smoother the visualization. Currently, as you can see in here, we have two types of resolutions, detail resolution, phi resolution, and they're both 8. Theta and phi talks about the direction of the points to render one particle. So if you like to change the value of resolution, I recommend changing them at the same time. So in this case, we have A for both, so it looks nice looking circle, or sphere, I'd rather say. Let's see if I reduce to 4. It means instead of A plus A, 16, we now use 8 points to render a particle. As you have imagined, now we have more like rectangle looking shape instead of circle or sphere. That's because we use less points to visualize. Let's bring it back to 8. And if you'd like to further enhance the visualization and make it more smoother, you can change 8 to 16. And each particle is rendered more precisely and looking like a better visualization. You can adjust the lighting to make the visualization brighter or add depth to it. To do this, you can go to Light Inspector and add some light source. So if you go to View and press Light Inspector, this should show up. To add light source, you press Add Light, and light source just showed up. You can adjust the type of the light source, location of the light source, and intensity of it. Currently, the position of the light source is located at x equals 0, y 0, and z equals 1. So if we adjust these parameters, this should move. Yep. And currently the intensity is 1, which is pretty strong. So you can also adjust it by making values smaller. Something like this. To add depth to the visualization, you need to look for ambient occlusion. If you look it up, they should show up. So if you press this, it adds some depth onto it, as you can see, and sometimes make the visualization look nicer. Threshold allows you to only visualize some particles you want. You can do this by controlling the value of the threshold. For example, if you only want to visualize a particle whose y coordinate is greater than a certain value, you do this by choosing y as scalar. And you change the coloring to white, and then you press an icon that says threshold. And once you do it, you see y is set as a scalar, and you can set lower threshold and upper threshold. Say I only want to visualize particles that is in between 4.42 and below 9.4. If you press apply, it shows up. You can invert it by pressing this button here. So it shows the bottom half of y coordinate. You can also show something that is in between the coordinate. Say between 2.45 and 5.45, you choose apply, and it shows up like this. You can of course invert it in the same way. And in this case, we chose the input scalar as y, but it depends on what input scalar you have in your data. So thresholding can be flexible with arbitrary input scalar you choose from. It can be ratio, scale, x, y, z coordinate, anything you want.